Hi, and thank you. My name is Torsten Engström, and I work at Vattenfall, and I work with nuclear security. First of all, I'm going to introduce Vattenfall a bit. We are 100% owned by the Swedish state. We serve roughly 7.5 million electricity customers and have 1 million electricity network customers and have roughly 2 million heat and gas customers, and we have 20,000 employees across Europe. Our main areas are that we work with power production, meaning that we work with wind, biomass, hydro, gas, nuclear, sun, coal, still, and solar, and also district heating. Our main operational countries are Sweden, Germany, Denmark, and Great Britain. So I work at the business unit that's called Fuel Engineering and Projects. We work mainly with our nuclear power plants, which are in Forsmark. And the goal of Vattenfall is to enable fossil-free living within one generation, which we have now specified to that you're supposed to be able to live your life without increasing the amount of fossil gases within 2040. And that is why we're working with farming, because we want to enable people to use nuclear in other countries. This is our main operation in Sweden, where we have nuclear power plants in Ringhals and Forsmark. And we're also looking at a feasibility study where we're looking at building new nuclear power plants within Sweden. We also work within the back end, so that we take care of the waste that we produce with a company that is called SKB. And other than that, we are looking at building a sustainable aviation fuel factor so that you are supposed to be able to fly without increasing the amount of fossil-free gas or fossil gases. And a short bit about myself. As I said, my name is Torsten Engström. I have a master's degree in nuclear physics, and I started working at Vattenfall in 2018. And my main responsibilities there is that I am the project security manager for our feasibility study. I am the functional area manager for licensing and security, and I work with the process leader for the nuclear security process. And that's why I'm here today. I'm going to talk a bit about security. So if you look at the future is not what it used to be. So if you look at the world and the state of the world in 2018, it would be very different from how it looks today. It was before the pandemic. It was before Russian invasion of Ukraine. We've had an increase in climate activists who are willing and able to actually perform threats against certain nuclear facilities and infrastructure in general. And we've also had an increase of foreign states' acts on critical infrastructure, religious extremism, and we've also had an energy crisis. And all of those things impact the way of security and the risks to our facilities. So if we look at what actually is physical security, this is the protection of our sites or our facilities and how that is performed and how it prevents and responds to likely events. Physical security often involves IT security and information classification. And risks to those things can be, we can have sabotage, we can have theft or tampering with our facilities, or they can be destroyed or other malicious acts. So what are we actually protecting? And the main thing is that we want to protect the people who live close to our reactors or our facilities. If you live near a nuclear power plant, you should be able to live there without having the fear of anything happening to you, your family, or your home. So firstly, we are protecting the people, and then we're protecting the environment as well. We don't want, if anything were to happen, that would have a fairly large impact on the environment as well. And of course, we are also protecting financial assets, because building nuclear power plants is fairly expensive. Some examples of nuclear power plants can be, or nuclear facilities can be nuclear power plants, fuel repositories, fuel transportation, spent fuel storage, or disposal facilities. But anyone who handles some sort of nuclear material needs some sort of physical protection. This means that if you're going to the dentist and have an X-ray, or if you're going to hospital and have a radiation therapy, they're using some sort of radioactive material. And this brings us to what we here call graded approach and defense in depth. And graded approach means that you have to look at the likely outcome of something happening and what the consequences of that would be. So if someone were to walk into the dentist office and steal the radioactive material that they used for your X-rays, that would probably not have that much of a consequence as if they were to steal nuclear fuel. Meaning that the protection for the dentist office is probably not as necessary as for the nuclear power plants. So how do we actually protect our operation? First of all, we make a threat assessment where we look at what are the threats and what are the capabilities of those who actually want to cause any harm to our facilities. For instance, climate activists are very willing to make some sort of action against our facilities, but their capabilities are very low. They're not likely to charge on the facility or nuclear power plant with any arms or with intent to actually harm people. The intent is usually just to make a statement or report. Whereas a foreign state or radicalized religious groups might have less capability, but their intent is more to harm people and to actually cause some sort of harm. So in order to actually protect the facilities, you need to have a cooperation between the ones who are running the site and the authorities. It's not reasonable for the site-operated radars to be able to protect the site towards a foreign military. Then you need to have a cooperation between the military, and as we do in Sweden, we have a site security team, and then we have a close cooperation with the police who will stand by and will help us if there's anything that were to happen. Security usually consists of these three sectors, where you look at personnel security, which is mainly insiders, and physical security, and also IT and informational security. And if we look at the first block, which is personnel security, this is one of the main risks within running a nuclear power plant from a security standpoint, and that's the insiders. Because these people have access to the site, both in physical access and also logical. So they have access to the systems, and they know how to look and how to work, and mainly how the plant is operated. And that means that you have to work closely with the government again, because you want to vet all of these people so that no one who has the intent to harm you or your facility has the access. And you're not able as an operator to check criminal or financial records for these people, so you need to have a cooperation with the government and authorities. And another important thing when you can do to actually increase your security is that you have worked very much with information classification. Everyone who works at the site should not have access to any information, so that you should only be able to look at those sort of files that you need for your job. This is especially important for physical protection. We usually don't discuss anything. I get the question a lot with what happens if the military invades and people shoot rockets in our facility, what are they capable to withstand? But this is not information that we share, because that would increase the capability of the attackers to know how much force they actually need to use to attack us. Another important part is informational security, as I said. If you apply information classification, you can section your information to those that actually need it. And since Russia's invasion of Ukraine, we've seen a very big increase in cybersecurity. And also we work in a modern society, so there's to be a trade-off there with how much information do you want in the cloud, and then do you want people to be able to work remotely, which most people do in a modern society, or do you want to use the old school method with paper and pen. And for some things that are in the high level of security, that's still what we do. We don't have any digital files for our main security systems. Those are written on paper and they're locked in a cabin somewhere. Because that's what we found to be the safest way, because then you actually have to get there to get to the papers. You can't perform any IT attacks. Another thing for physical security is that we have the 4 pillars that we usually work with. These are deter, detect, delay, respond, which are fundamentals within security. We have deter, which is that we want to deter someone from actually performing an attack. And I think that this is something that you know from your regular lives. If you walk around in your neighborhood, you will probably see some people having a sign on their door that says beware the dog, which is likely that someone will not try to break in if there is a threat of them being attacked by a dog if they do so. And if that burglar then walks to the next door and tries to break in there instead, there might be a burglar alarm, which is something that we use to detect that thief. So these are things we work with, and then when that burglar alarm goes off, we have the delay system. We need to delay the thief as long as possible so that someone can get there and actually intervene. And this can be done in multiple ways. We can do it with fence or barricades or something like that. In our homes, we usually do it with security doors. If you have a thin wooden door, it's very easy to break through. If you have a door that's bolted to the ground with steel and also have steel sheets, you have to drill or saw or anything to get through, and that will take some time. And then delay the response, and some of our neighbors will probably hear the noise and call the police, who will arrive and out. For nuclear perspective, this can be, as I said, a cooperation between the state and the regulator. In Sweden, as I said, we have armed security on site, but we still rely on police in order for support. And this is done differently in different countries. For instance, in Spain, they have a close cooperation with the military who will be able to assist if anything were to happen. I also like to say that nuclear is a small target, which might seem strange. On the picture to your left, it's Forsmark 1 and 2, which is one of our nuclear sites in Sweden. We also have a third reactor that's not in that picture, but it's there in the area. And what I mean by small target is that it's much easier to protect a nuclear site than, for instance, the picture to your right, which is the Grand Central Station in Stockholm. And this is because the entrance to the nuclear power plant is only by one road. On all the other parts, there are fencing and barricades so that you won't be able to penetrate. And everyone who is there is vetted. They're checked by security when they arrive, and only those who are allowed to be there are on site. And now, if we look at the Grand Central Station, there's thousands of people there every day. You have no idea who they are or what they're doing there, and they're allowed to carry whatever they want, basically in their bags. And there's many entrances and exits, so that it's very much more difficult to protect, for instance, a train station or an airport. And it becomes fairly easy because you will know where you have to place your defenses in a nuclear power plant. Security is also a continuous work. It depends on the measures you take depends on what stage you're in. And this means that if you are in the building process, you need to look at is it likely that someone will place some explosive in the foundation or something like that. And then you move on and see what measures you need to take in order to protect the site during the operation and then the commissioning. This also depends on what material you have on site that you need to protect. But this is what we call the security cycle, which is that you plan, do, check, and act. And during the planning, you see what is the threat and what are the capabilities of those who are willing to attack. And then you make a plan for your security and their measures, so that's what you do. You implement those measures, and then you have to check to see if the things you have implemented actually have the desired effect that you want. And if it doesn't, then you act, and then you get back to your planning phase. And this is something we do on a regular basis. It's regulated in Sweden that you have to do it at least once a year, but it's done much more often than that. And if something were to happen within the world, like for instance when Russia invaded Ukraine, this was something that we did immediately, and the security process and then the physical security for all of our nuclear operations were updated immediately after this because we saw that the risk had increased so much. This is a picture of Greenpeace at Forsmark. It's from 2012. And Greenpeace broke into Forsmark, which was one of the nuclear power plants we saw earlier. And what they did was that they went out and got some fire trucks and a bunch of ladders and got up to the fence and brought those fire trucks and ladders to the fence, and then basically went over. This was something that Greenpeace were very proud of. They said we managed to break into a nuclear power plant in Sweden, and said that obviously nuclear is not a safe thing to have because we were able to break it. But we, from a security perspective, saw this as a very positive thing. We have implemented our 4 pillars, which is where the tower detects and so forth. So we were actually not able to deter them from doing their operation, but we were able to delay them with our fence. So when they arrived, they had to place their ladders, and the security forces saw that and noticed that they were trying to get in. And the security force was there to respond, and also the police were called. And they didn't get that far into the facility, so afterwards they were basically just fined. But in interviews they were proud and say we got into Forsmark and so forth, but they only got into the visiting center, so they got as far as the school classes that we have on tours to promote nuclear. But anyway, this is something that we learned from. So we saw that obviously the barbed wire on top of the fences and the fences were not enough security measures, so we had to do some sort of update on this. And the measures that we took was, one of them are that we placed electrical fences within over the barbed wire, which should deter most people because you don't want to lethal dose of electricity. And also on the ground, I don't know if you can see, but basically this was just asphalt during that time, and now there's an uneven rock formation there, so that's much harder to place any ladders there. You can obviously if you bring some sheet, but that's something that you have to do, and that will delay the time it takes to get over the fence. Another event that was very significant within nuclear was 9/11. Before that, we didn't really think that it would be reasonable or for anyone to break into the nuclear power plants and place an explosive device or anything. But after that, we had to reevaluate. And what this meant is that we increased the security not just on site, but also for our entire force. We now, after this, we do a much more extensive vetting process of all our employees. And on site specifically, we placed the same sort of security measures as on airports that we have. Everyone is X-rayed for metal objects and weapons, and everyone's bags are as well. So now you're not able to carry what you ate into the nuclear power plants anymore. We also implemented another system, which is that we set up scans for going out of the nuclear power plant. And this is not for weapons and so forth, this is for nuclear materials. And this serves 2 purposes. And first of all, you can see if someone is trying to carry out nuclear materials, because we don't want anything to leak. the nuclear power plant so that they shouldn't be able to carry out. And also this will tell you if someone who has been doing work on the site is contaminated, and that would be hazardous to their health. Also, we have set up a vehicle checkpoint, so that you're no longer able to just drive up to the gates of the nuclear power plant, but there's a vehicle checkpoint about a kilometer out, which will then, it's not difficult to drive through, it's just a gate, but that will of course alert someone and then delay and call on the response team. And finally, I like to say that no one is alone with nuclear. And what I mean with this is that, as I said, at Vattenfall we're doing our own feasibility study. And we haven't built any nuclear power plants since the 70s or 80s. And the world today is very different than it used to be. So today people want to work remote, as I said, they want to have cloud-based systems when they work. And the operators that we're working with also want to have cloud-based systems. So we at Vattenfall are not used to this type of IT environments. So we don't really have any experience in that. And what we did was that we called around to see who has been building nuclear power plants at the moment. And Hinkley Point C in Great Britain is one of those sites. And they're very willing to help us to a very big extent. They said, we just went through this journey, and this is what we found, and this is how we work today. And we had a big problem with our regulators. They thought that a cloud-based system wouldn't be safe enough. So, but we have had a long journey discussing this with them, and actually got them to change their mind to the point where Hinkley Point C think that their regulators now to liberal with security measures. But they actually said that they are willing to help us talk with our regulators, so that they set up meetings with their regulators to talk to ours in order to help them to change the way that they look at nuclear and critical infrastructure. And there's always a bunch of international agencies that are willing to get aid from as well, such as IAEA, Bono, and YouTube. Also, one thing I would like to add is that working with informational security is quite tricky. Our, for instance, email servers are set up not within Sweden, but our servers are in Dublin and Great Britain. So if I get an email that's bounced within Europe a couple of times, and then I arrive at my computer. And for informational security, that's a big problem, but which we don't really know how to handle. But then again, we talked to the British people who has gone through this journey, and they explained how they solved those problems and were very willing to help us. And I think that's it for me. Is there any questions?
Thank you, Torsten. Tuumaelektrijaama turvalisus ja julgeolek on ilmselt selline, mis meid kohe käivitab ja kindlasti on teil küsimusi. Ja võib ka eesti keeles küsimusi esitada, Liis aitab meil tõlkida või keegi. Et palun, küsimusi. Ja palun.
Okay. Hello, I'm Igor Taro. I'm the chair of the Environmental Committee of the Estonian Parliament. I would like to ask about the cost of security. How is it distributed? You said that there are different solutions where the producer of energy has some level of security measures, and then you have additional cooperation. If you have additional cooperation with the police or with the military, that means that the state has to develop some additional possibilities for the military or for the police. Is it only the cost of generally of the taxpayers, or do you have to contribute somehow to the state?
We contribute our the cost we take as an operator is that we stand for the cost of the people who are working on our site. So for everyone who's outside, such as the police or if the military would get involved, we would not be part of that cost. We're only responsible for our own operation and cost the public to the students. Thank you. Inbox.
Tack för presentation. My question is also about security, and is it somehow regulated how much gas has to be on payroll for the power plant? And another question is regarding to war in Ukraine. We see there are much coming up drones, different type of drones. Do you have ideas, or is our plant also protected from attacks by drones from here?
Well, for the first part, that's done different in different countries. In America, they have a standard that says you have to be this number of people at the site at all times. But in Sweden, we don't have that, but we have to prove to our regulators and the government that our site is safe. By doing so, we dimension against certain events where we say if this were to happen, we have that many people that can respond to that sort of event. And if they deem that to be safe, then that's enough for them. And we also look at the state's assistance within those, so that we were able to delay any attacks for a certain amount of time, and then we estimate that police and some other systems will arrive. And so it depends on the regulations within the specific country, I would say. And for the drone part, I'd say it's a difficult question, but there are certain measures that are taken to prevent drone attacks. But again, what type of measures we have taken, I'm not allowed to discuss. But of course, it's a problem. But it's something that we are aware of and have taken measures for.